My name is Ian Harrigan, and thank you. And I'm the author of HaxeUI version 1. And what I want to talk about today is the rewrite of version 1. It's an OpenFL library, version 1, and I wanted to rewrite it to make it a little bit more flexible, as I'll explain in later slides. So there were some things about version 1 which were good, bad, and very bad, really. And so I just want to go over some of them. I'm not going to go over all of them because some of them will be explained a little bit better in subsequent slides. But what I mainly wanted to talk about is some of the good things that I like about it. Is it's very easy to set up, so you can get a UI running pretty fast. Yeah, there's not too much boilerplate. It's not difficult. It's got a pretty decent component set. I'm quite happy with that. Scroll views, drop downs, pop-ups, all the stuff that you generally need in an application. The script system I quite like. It makes things easy to prototype. You can check things are working without having to really mess with Hex code if you don't want to, which is pretty useful. And of course, there's the style system, which it's a CSS type style system, and I really like it. I think it's perfect to use a DSL for this kind of application, or this kind of framework, sorry, because it lends itself perfectly to changing UI elements without actually having to use code at all. Of course, one of the bad things is there's essentially no documentation. As I think Simon will know, the best way to get help for is to come to the IRC and hope that I'm there. So that's not great. The text input. Version 1 is linked to OpenFL Legacy, which is a big problem because it doesn't have decent text support. So that's something that needs to be changed, obviously. And Next, OpenFL Next has much, much, much better text support. So that really helps. One of the things I really don't like about it anymore is the default themes. So they're kind of blue, a little bit cartoony, and I think generally make an application look pretty unprofessional. So that's obviously changed as well. The CSS format, sorry, is pretty bad. It's using camel case instead of dash case or whatever it's called. And I use a lot of custom selectors, a lot of custom attributes, which is not really good at all. I overuse them essentially. And again, anyone who's used HaxeUI will know that the auto-sizing in version 1 is really messed up. It can auto-size things, but it's not particularly clever. You have to be quite explicit about what you want auto-sized, what you don't want auto-sized. It doesn't know the difference between auto-sizing width and height, so it can break a lot of things. And generally, it's just a bit of a mess. It's a real problem. So that's also a very, very bad thing with version 1. So what I want to show as well is just an overview of how version 2 fits together. So as you can see, you've got your HaxeUI core. Now this does basically all the heavy lifting. This is your style engine. This is your layout engine. This is the script engines, your binding support. This is essentially the user's universal access into the framework. Then I've got a concept called Backends, which are small pieces of code, small libraries essentially, that HaxeUI core then delegates calls to. And then that in turn calls a target framework, which can be either OpenFL, Flambe, Car, Pixie.js, Enemy, Lux, or Lux, and Exception widgets. Of course, these are all actually working. These are all actually working fine. And you can add, there's no limit to what you could add to further ones. You could have a Swing backend, or you could have a C# backend. You really can do whatever you want. So another thing I wanted to show in this slide, which I think is pretty important, is there's multiple paths to different platforms. Now, this is obviously a really good thing. So what it means is you have your mobile build, let's say. Maybe you're using OpenFL for mobile, and that's all fine. But maybe it doesn't work on iOS, let's say, for whatever reason. So that's a possibility. Well, then you can just flip a switch, use a different backend, and now you can deploy, for an iOS build, you can use Car, for example. Or you could use Pixie.js or any of the other backends. Your application simply doesn't need to change, and that's really good. It's also nice because you can actually test out frameworks. Maybe you want to test the performance of all the frameworks, but you don't want to have to rewrite your application or a test application each time. So you can just write your test application using HaxeUI, and then just build multiple builds with different backends, and see which one suits you best. So another thing about version 1 I want to quickly go into is the class hierarchy. It's a bit of a mess, as you can see. I think the reason why I went down this route was to try and emulate the OpenFL or the Flash API, which is very similar to this. It doesn't really make sense to do it this way. For example, state component and stylable display object. There's some quite nasty code inside version 1 that is there to sort of bridge this layer between them, because they're kind of trying to talk to each other, but stylable doesn't know that it's a state component, although it is, and there's some nasty casting and just generally a bit of spaghetti code in order for those two layers to talk to each other. So since I was rewriting the whole thing, obviously it's a good opportunity to finally clear that up properly. So now you've just got a component. So a component automatically can already have children. It's automatically stylable. It's automatically a state component. It's all of these things out the box, which is essential. There's interactive component, which is another layer, but that's really just a placeholder at this stage. Eventually there's going to be a focus manager, and this is simply telling the HaxeUI core that this can gain focus. So it's essentially an empty class at the moment, but I'll use it a bit more in upcoming code. Right. So here's one of the concepts of HaxeUI, which is the concept of a backend. Now, a backend is quite simply a tiny chunk of XML that lives on the class path. It's automatically discovered by a macro, which goes through, scans the class path, finds it with config.xml, which may change if I start getting clashes, and starts loading little pieces of information from it. The main part that this does via macros is it starts replacing classes. So all over the HaxeUI core, there's base classes like component base, assets base, screen base, these sort of placeholder classes. Now what the macro does is it comes through, gets the information from this XML file, and then starts replacing the classes, replacing the type, at compile time. So for example, your component base then suddenly becomes haxe.ui.flambe.component base for the Flambe backend, that is. And the same, very similar for all the other backends, OpenFL and all this kind of stuff. And this means that HaxeUI core, the component, can then call classes, can call functions inside itself that don't necessarily lead to specific code inside HaxeUI core. It leads to a backend library. So that's obviously the most useful part of this. There's a completely optional section, which is the native config. Now, what this does is everything in HaxeUI 2 is a behavior. Well, I say everything. All of the things like .text, .scroll position, .position, .value, all of these getters and setters, if you like, that you can use from code or you can use in XML, they're all actually behaviors. So it calls a default behavior, which, for example, in the case of a button, it will create a label control, add it to the component, redraw the layout and all of that kind of stuff. But if you're talking about a native component, you don't have control of the layout, you don't want to have control of the layout, you don't want to add a button, you don't want to add a label to a button. This is all handled by the host operating system or the framework itself, the host framework. So what this does is that you can then substitute a behavior. So for example, we've got a button up there in the HTML5 one, and you've got the text, and instead of calling the default behavior, it calls this new one. And in the case of HTML5, that creates a span element, adds it to a button element, quite similar to what the actual core framework does. In the case of HX widgets, that simply sets the controlled value, the window value, the window text, sorry. So this basically enables you to substitute values, substitute behaviors into the core framework instead of using the default ones, which obviously don't make sense for native components. So the other thing, this is quite important, is size reporting. So if you tell HaxeUI, I want a button, a native button, let's say, and I want it 100 pixels by 100 pixels. There's no problem, the layout system will go away and it will, request a 100 pixels by 100 pixels button, no problem. However, most of the time you don't want a 100 pixels by 100 pixels button, and you certainly don't want to be explicit about sizing things because operating systems are vastly different. On OS X, for example, a button is very different to Windows, so you don't want to start explicitly sizing things. So in order for the layout system to work, HaxeUI needs to know what the operating system thinks that, created that button as. So this is done with the size attribute here. So basically, if it's auto-sized, either by width or height, this piece of code is run, and that's where it gets the size from. So again, for WX widgets, That's like the best size, and that's WX widget speak for, you know, what it is, the contents of it. So that's including the icon, and it says, okay, well, this can all fit in, you know, 20 pixels by 100 pixels. That's your best size. So HaxeUI hooks into that and says, what did you think this should be sized as if it's auto size? And it gets that value, and then it can use it in subsequent layouts. Custom layouts, it's quite rare to use these, to be honest. Size is usually enough. But for example, with the HTML5 backend, a button has a completely custom layout just because it was easier. There's a few ways to do it. There's a few ways to have created the layout. I could have just created DOM nodes and, you know, added CSS properties. But since I've got an invalidation sequence and a layout engine, and I've got all of that stuff working, it doesn't hurt to also allow native components to use it as well if they need to. So that's that. Yeah, so now another part. These are optional, really, but they're also pretty important, is the modules. So modules have a few different roles inside a HaxeUI 2 application. The first thing that they can do is they package Hex resources. Now, the reason why this is important is because generally the HaxeUI backend handles the drawing images and all that kind of stuff. And it does that what it thinks is native. So for example, in car, you have a car image. In Pixie.js, I think it's a pixie.graphics. In HaxeUI widgets, it's a Hex resource, et cetera, et cetera. So the backend handles that. But what you don't want to do is you don't want to have to repackage your resources every time you want to move an application across. If you can use the native resources to the framework if you want, and that's totally fine. But for example, let's say the default theme. The default theme, I think, has got, you know, little icons for the up arrow and down arrow, the checkbox. Now, you don't want to have to, when you create a new application with car, you don't want to have to package these resources in a way that car understands. Or when you're using, you know, Flambe, you have to package these resources in a way Flambe understands. You don't want to have to do that all the time. So that's what this does. This allows you to recursively, again with a macro, recursively go through a set of directories and package them as Hex resources. And if you want, you can, it gives it a prefix just to make it, you know, so it doesn't clash and things like that. Then later, once those resources are in, you can use them as icons, as you can see in the CSS, or you can just use them as an image, you know, as the resource for an image. So they're now part of your application. They're Hex resources, and they essentially come with the HaxeUI core module. But you can have your own module, and you can do exactly the same thing to bring your other resources in, should you wish to. I'll go a little bit more into resources later, because they're pretty complicated. But for now, it's suffice to say that you can package Hex resources, and yeah, they follow the library around. Components. This is, again, it's a completely optional part. If you don't use this section in the configuration, then you can still use HaxeUI 2 without any problems whatsoever. You just won't be able to use the XML part, because it won't understand. Basically, your component registry will be completely empty. So when you say, you know, button in XML, it says, well, I don't know what that is. So what this does is it defines component classes and packages. So again, with the macro, it goes through, you give it a package, it finds anything that extends from component, which is the base class, and automatically adds it to the component registry, which then later, if you're using XML, you can refer to it in XML. It also allows you to alias certain components, as you can see, I think in the last line. So you can import like a label, for example, but you can say, hey, I want to use this as text. Now, the reason I've added this is, for example, in version 1, if you wanted to display text on the screen, it was called text. Now it's called a label, but in order to potentially ease migration from version 1 applications to version 2, you can just alias in your module the label to be text, and it will work exactly the same. So that's components, again, completely optional if you plan on using it only through code. Scriptlets. Scriptlets had a bit of a revamp in version 2, because if you're not talking about performance-heavy application, which generally if you're talking about a UI application or a tool or something, you're not massively focused on performance, I think. And scripts really help, as well as the ability to send code, essentially, down the wire. You can keep an entire application as a single script file, or a single XML file with a script inside it, and it will actually have functionality, which is really quite cool, you know. So you can have like a container application, and you can bring in applications in raw text and start making them actually do things. So with that in mind, I wanted to sort of clean up the scripting, because it's a little bit of a pain using HScript sometimes. One of the problems that HScript has is you have to use fully qualified class names. So if you want to create a button, you have to do hex.ui.components.button if you want to do that. And that's a bit of a pain. It's not a problem, but it's just a little bit annoying. So one thing that this does is it allows you, very similar to the components section, it allows you to import packages and classes, and it will automatically add them to a sort of short form registry. So that means in future, if you use button, for example, it will go in and go, okay, I know when you say I want a new button, it overrides the HScript interpreter and says, right, so you're using button, I think you actually mean hex.ui.components.button, and then it just makes everything a little bit cleaner, so you can just go new button. You also have the ability to keep classes, because of course if you're scripting, DCE actually works in version 2. DCE in version 1 simply didn't work. All classes were always pulled in, and essentially a reference was made to them. So you never got rid of any classes. That isn't the case with version 2. DCE works as it should. So if you don't use button, then you don't have button in the result, which means if you try and use it from script, then obviously you won't be able to make it. So what this does is you can say, well, I actually know that I'm going to be using buttons, so I want to keep buttons, or in this case, I want to keep a component, and I want to keep everything in the components package, which means the button will now be available because it won't be DCE'd. It will add some metadata, again, via a macro. So another thing is, obviously, often you want to use, say, math, you want to use std, and all of those sort of things. Now, normally, with HScript, what you do with that is you, in the script variables, you add a reference to it, to std, and like name it std, for example. Of course, as a user, you won't have any access to the script interpreters because they're managed internally by HaxeUI. So what this line does is it simply says, right, in every script interpreter, whenever you go away and you create a script interpreter, can you put standard in there, and can you put math in there? And it's not really maybe the right attribute name, but I've called it static, just to say this is a static. But it doesn't have to be these... it doesn't have to be math or standard. I mean, you can be the animation manager, it can be HaxeUI classes, it can be your classes, it can be any helper classes that you want to be exposed to the script by default. And again, relatively simple, this one, the themes. It allows you to define themes and resources. At the moment, a resource is just a list of CSS files, really. But what's important here is if you have, say, 10 modules, you can add to existing ones. So global is a special one. Global is applied. Those style sheets are applied regardless. The default theme, that's actually a name. So it's not, doesn't necessarily have to be default. It just means that the node name is the name of the theme, and it happens to be default in this case. And then there's my theme, which extends parent. So essentially, in that setup there, what would happen is global will be applied, then the default theme will be applied, and then finally your theme, mytheme.css, will be applied. And if you had additional modules from other projects, you can also just add an entry to my theme, for example, and then it will load that resource as well, which is good for if you're creating a library of, say, custom components, and you want them to be themed in default with something, you want to tweak something, then you can just add to it there. Right, so now arguably probably the most complicated part I found of rewriting HaxeUI was resources across frameworks. Every framework has its own way of doing something, and it took in fact, I wasn't even sure that I had a candidate framework until I got this working, because this is obviously a very, very fundamental part of everything. So what I had to do is I wanted the resources. I didn't necessarily want someone to have to create a build system and repackage their resources if they were making a game, let's say, as something that HaxeUI understood. I wanted HaxeUI to work with the framework. So with that said and done, HaxeUI uses whatever the framework does. So it's a car.image, or it's a JS.image element, Hex resource for WX widgets. For Lux or Lux, it's a Phoenix.texture, which I believe is changing soon. So that's fine, and that works pretty well, assuming you're using those classes as your images. What's an issue is, as I talked about previously, if you're using Hex.resources, which is essentially ends up as a load of bytes, we want to convert that into something that the framework understands. Now, for certain ones, this is very easy. For OpenFL, this is pretty simple because it's just bitmap data. For HTML5, it was pretty simple. I just converted it into 64-bit, base 64, and used that as an image source. The harder ones were things like Lux and car. And so I had to dig deep into the frameworks and see how they're actually doing it themselves. But as I say, it is actually working. And so that's working well, really well, actually. It's also, of course, they're totally asynchronous. Every asset is asynchronous. This just makes sense. I mean, I think there's very few frameworks that even have synchronous resources. I think WX widgets could handle it, but the other ones, they use asynchronous anyway, so it's no problem. Now, the important part about the resources is they're totally transparent to the users. So when you say, for example, in your source or in your XML or in your CSS, this image.png, if it's a Hex resource, then it gets extracted as a Hex resource, gets turned into the target framework, and then you can use it. If it's already in the right format, then it just gets used as it is. But the important thing is the user really doesn't know, or for the most part care, what format it is in. So they're just simply, I want this image, it's part of the framework, or it's part of the default styles, for example, which get compiled into the finished source, and you're just using it. You don't really mind what's happening behind it. And it's also important that the framework, so your application, if you like, takes precedence. If you've got two resources of the same name, one is, let's say, in HaxeUI core, and then there's your one, then your one will take precedence. So that means that if you wanted to change the default styles, just drop a file in, which is nice. So that's a bit about the technical aspect, I suppose. Now this is where things get quite interesting and fun. So there's two types of components inside HaxeUI. The first is composite components. Now this is the default for everything. A component starts its life, even if it's brief, as a composite. And a composite is essentially a component that's built entirely out of other HaxeUI components. So again, for a button, that's a component, and inside that there's an image component, and inside that there's a label component. And then there's a layout engine which decides what it wants to do, and a button layout, for example, if you want it on top, on the bottom, on the right, and all that kind of stuff. Same goes for sliders, it's scroll bars, everything is a composite if you want it to be. Now there's a few things about this that are good. First of all, themes are totally applicable. Everything in HaxeUI is themable. It's all done with a CSS type language. And they're 100% applicable. You might lose, like, say, rounded borders, for example. I think Card doesn't support, at the moment, the backend that I've written doesn't allow rounded borders. Neither does Flambe or Looks. So it will simply ignore those CSS properties. But you'll still get a square, and it will look very, very similar to what you're looking at to the left. So it's very, very consistent across platforms. So an application will look the same on OS X, it will look the same on Linux, it will look the same on Windows, or the web, or anything. I mean, you have a very, very consistent application. And the logic and layout is completely handled by HaxeUI core, which is both good and bad, as we can see with the native components. Native components are a little bit different. The creation of the actual component is delegated to the backend, so WX widgets in this case. Or HTML5 is another way that you can get native components. And the themes, they work, but they most likely are selective. And what I mean by that is, for example, WX widgets, you can change the background color. That's not a problem. But you can't change the border color. So if you say you wanted a red button, your red button will just be a Windows button with a red background. So there's no real control over this. This is just, it's what the framework allows. I think Qt, for example, will allow a lot more control over that. And that's certainly something that I'll be looking at. So it's really up to the target framework, WX widgets, what it will allow you to style. It's a little bit difficult to create entirely custom UIs. So if you wanted, big sliders or something really pretty, very, very custom, it's not really a good idea to be using native stuff. Especially, like, for example, on OS X. OS X seems to really not allow you to do certain things, like changing button sizes seems to be unnecessarily hard. But it is what it is. There's nothing you can do about it. And like I went into, the sizes get reported back into the framework via the size attribute in their native config. What's also good, though, of course, is you can mix and match these components together. And this is really, really, really important. Because what it means is, as I said, if you wanted to have a custom UI, you wanted native buttons, you wanted native scroll bars, because scroll bars behave very, very differently across operating systems. So you want the user to feel at home with their scroll bar. But you want the sliders. Let's say you want these pretty sliders. So that's fine. You use a native UI and a composite slider. So you can really mix and match all of these components and all of these things together, which is brilliant. And you can sort of get the best of both worlds and fill in the gaps. So, for example, range sliders don't really exist on HTML5, but that's fine. So you could just use a composite slider, should you want to, or redesign your application. It's your choice. Right, integration. This is version 1, integration. I remember I was hanging around in the IRC room, and this is quite a long time ago now. And someone came in and asked me to help them to put a button on their application, on their UI. And I had to explain this to them. that you have to open a pop-up, you have to handle the sizing, you have to do all of this, basically, jump through all of these hoops just to get a button. And if I remember correctly, he kind of gave up. He said, this is ridiculous, and you know, left it. But it sort of stayed with me, because it is completely ridiculous to have to go through all of this effort when really you just want a button, and the end result that you get isn't particularly great anyway. You know, you essentially have a root component floating over the top of your application, very, very separate from your actual application. So it's not something that I was particularly happy about. So with that in mind, now this might look a little bit scary to start with, but actually it's the right way to be doing things. So first of all, component base handles all the library-specific stuff, like OpenFL, for example. But what's important about that is component base that lives inside the HaxeUI OpenFL extends sprite. And this is great because that means when you create a button, it's essentially a sprite, which means it handles all its own drawing and everything as a sprite. So the framework understands it. Sorry, OpenFL understands it. So now you can just add it to the stage like you would anything else. So you can actually start integrating HaxeUI into your application without having to, you know, create all these pop-ups and all these roots and all of this kind of ridiculous stuff. HTML5, very similar. It contains an element, which you can then add to the DOM anywhere you want. Car exposes a render function. Obviously, car has a render loop, and so it exposes a render too. And then you just give it the graphics, and bang, your UI appears on stage. Same for, very similar anyway for Flambe, which is a sprite, so you can just add an entity and use it in your UI. Again, this all integrates nicely with the framework, the choice framework. Lux seems to just automatically draw. I guess it's got some stuff on there that automatically handles the render loop for you. And Pixie just extends graphics. So again, you can just add it to the stage. Now, you don't have to get into these details if you don't want to. It simply means that you can. So what you also can do is there's a screen element. And you can just add an item to the screen. And that essentially calls one of these functions for you, depending on the back end. Again, screen has got a screen.base counterpart, and that handles the platform-specific stuff. Again, car's a bit different. Car has a render loop. So, for example, if you were using screen to add your components, you would also need to go through the screen, top-level components in the screen, using in the render loop, and then actually render them onto the stage, or the screen, sorry. Now, one way around that is to use this HaxeUI app, which is my personal way of doing it, but you certainly don't have to do it this way. And this actually handles the render loop for you in a car application. And in a WX widgets application, it handles the initialization of the top-level frame. It starts up the event loop. It basically does everything for you. So you can just keep your application as an application and never have to worry about anything platform-specific or, sorry, framework-specific. It just kind of works across platforms. And this is my personal way of doing it, but like I said, it's totally optional. It's a helper class, essentially. So yeah. Now, binding is another thing that's quite useful. Version 1, there was no binding at all. So you would have to, if you wanted to change the value of a slider based on a slider, you know, you would have to write that code yourself, which is not great. So it takes a very simple form. So basically, you give it a chunk of XML, and you say, right, I want to bind this, you know, this target to this source, as you can see in the normal normal form. So in that example there, you've got two sliders, and they're changing a button's width. You have a target a property, so it automatically defaults to the value property, which changes from component to component. But you can also use anything there. It could be text, it could be H scroll position, V scroll position, width, height, anything you want really. So yeah, so that's binding, and for the most part it works. I think I might look into next the ability to bind to variables as well, which would be nice in your controllers. Speaking of controllers, another thing I really like about version 1, certainly, is the ability to use these macro-based controllers. So you have a chunk of XML, you use a macro to build, essentially, that XML, and it builds Hex source for you, or yeah, it builds anything with an ID, becomes a member variable, a correctly typed member variable. So, for example, the counter field becomes a counter field text input, or text field, I can't remember the name of the class. And this is really nice, because what it means is you can not have to worry about linking up events, creating member variables constantly. You kind of go away and it's all done for you, and now you've automatically got an add button as part of your controller class. You've also automatically got a Hex button, all of the stuff that's in the XML. And this is really, really nice feature. It doesn't really show its worth right there because it's quite a small application, but in bigger applications it becomes quite invaluable. What's not great about it is it's not a component. It's a specialized class, which is extending from XML controller, and you have to attach you have to, use a specialized variable on it, view, and then attach that to, to the root or wherever you want to display this. So it's not great. It works, and it's a good workflow, I think, but it's not brilliant. So that's certainly been revamped in version 2 as well. And so it's not called a controller anymore. Now it's called a custom component. So it looks a little bit bigger, but that's because it's doing extra stuff. So the first thing is scripting. This is really, really cool, actually. It means that you can have, previously in HaxeUI 1, every script interpreter or script engine, there was only one for every application. So if you had a variable, let's say counter, then you would only have one instance of the script engine, therefore one instance of the variable. So you couldn't do something like this, where the counter is itself handled, is incremented in the script, because you would only have one. So the components would start interfering with each other if they were using scripting in this way. So you would have to keep the counter as a member variable of a Hex class in order to isolate it. That's not the case in version 2. Every component has the potential, if it wants to create its own scripting engine and use that, which is brilliant. So that means that you can handle the counter, as you can see here, internally inside the script, which is very nice. And the other thing that this does is, since it's a component, now the actual class extends component, as you can see, counter extends component, you can just drop this in to screen.instance.add component. You can just, it's a component now. So you just drop it on like you would a button, like you would a text field, any of that sort of stuff. Also, this automatically becomes available now, since it's a component. It gets automatically registered in the class registry for XML. So you can just automatically use it for XML. And finally, you can start passing values to it. So you, for example, here we've got start value, which is just a simple getter and simple setter here. So they're really useful. They're not really controllers anymore, they're custom components, but I think they're a lot more useful in this form. So what's next? So first of all, I want to do some more components. First of all, obviously, I want an alpha. I want to get some code out there, because I've been sitting on this for quite a long time now, and I'd like to get some feedback and actually start seeing people using it. So I'm going to get an alpha out soon. There's also then components, more components, overlays and dialogues, which is essentially done, I think, but I didn't update the presentation. Drop-downs, list views, and table views. These are going to be a little bit more complicated, because I want native counterparts. I want the ability for you to have the option, at least, of using a native list. So that's going to be a bit complicated. I also want to look at some more backends. Now, as I said, the WXWidgets backends is fine, but Qt seems a lot more flexible. I've actually started writing externs for Qt, and it seems very, very straightforward, and I think I'm almost 100% sure it'll work. So I would like to also create another backend, because it doesn't hurt. That will be Qt. Heaps, I took a look at Nicholas's Heaps library, and it seems very straightforward, lends itself perfectly to this sort of stuff. It has the concept of sprites or a drawing surface, which means that it's very, very simple to implement a backend. Same goes for Flixel. I was talking to Lars, I believe, and yeah, it seems like a lot of people might get some benefit from a Flixel backend as well. So, and again, it has the concept of sprites and drawing surfaces, so it's a really, really simple backend to write. And possibly maybe just for fun to see how it works, a PDCurse's text-only backend, just to see if what assumptions I've made that there will be pixels. Also, another thing that's going to be quite important soon is making this making this mobile ready, sorry. So that means that the composites, for example, you need to be able to use your finger to drag the list views, the scroll views and all that sort of stuff, like version 1. But it certainly doesn't exist at the moment in version 2. They're not mobile ready at all. You'll have a tiny little scroll bar, and you probably won't be able to touch it / use it. So that needs to be fixed, and as well as DPI and auto-scaling that comes in the same way. And I want to make another Android backend, a native one, so that it will create a native UI for Android. I've managed already to create some test project that uses HX Java to create a native UI, and that works fine. So now it's just literally a matter of wrapping that up into a backend. And finally, iOS, I haven't got a clue. I don't know anything Apple. I don't own an Apple device, so my hope is that someone will pick up the iOS side and just write their own backend for native iOS. So next, I just want to go through a little bit of a slideshow of all of the different backends. Obviously, I don't have a VM on this tablet, on this netbook. So I just want to go through some screenshots of basically everything I could get my hands on. So this is a demo application, or the demo application, in OpenFL. This is a composite, so everything is drawn by HaxeUI. It's the same thing in Flambe, Car, and Lux. it's a little unfair maybe to lump them all together, but I just simply wanted to show that it essentially looks exactly the same, but without maybe rounded borders. But apart from that, it's all there. This is the same on Windows Native. So this is the exact same application, but running as a totally native Windows application. Nothing's changed, no source code was changed. This is just literally compiling a different project on the command line, and it outputs this. Exactly the same application running under Ubuntu, which is a Linux native application. So again, nothing changed. It just works. And the same again running under OS X via a native backend. So as you can see here as well, the buttons are a little bit hard to size. They don't work quite right. But this is seems like it's a limitation of OS X. Now there's some HTML5 composite. There's quite a few coming HTML5 backend screenshots because there's quite a few flavors. So there's just your bulk standard composite, which means everything is drawn by HaxeUI. This has got no framework dependency. It just outputs a DOM tree, which is great. The same thing as a hybrid, so which means it uses native controls where possible for buttons, sliders, all of these kind of things. That's fun. Exactly the same on Firefox. The native controls are a little bit closer to what the operating system actually looks like, but again, it uses native where possible. Same thing on a Firefox browser, but with Ubuntu. And exactly the same thing on a Firefox with OS X. And finally, IE. So this is Edge. This is what it thinks an UI should look like natively, which I don't particularly like, but it's using native controls. And I think that's me. Yeah, one thing I wanted to possibly show you, if there's time, is there's an application that I've been working on, which is to, I think we've lost the feed, haven't we? Can you see my screen? No? Oh, okay. Right, there you go. So there's a real application that I wanted to show here, which is a HaxeLib manager. So this is a totally native application, and it's completely written in HaxeUI and compiled to native. I mean, it works on OS X, it works on Ubuntu, and even works if you wanted to compile it as a composite OpenFL, for example, using CPP. So it's really, it doesn't do a huge amount yet, but I've been using it as sort of to test how things should be working. And so you can, for example, you know, you've got all of your different versions here. You can, again, these buttons don't actually do anything yet. But the point is it's the flow is there. So these are all native dialogues inside a native application. You've got information about the project. You can, you know, look up Sing Majesty, which is Joss, for example. You can see all of his previous projects, all the ones that he's registered in HaxeLib, you know, and you can get all of the information and all this kind of stuff. So yeah, so I just wanted to show what is possible. I mean, you can write real applications with very, very little effort, to be honest. I mean, it took a little bit of effort, but that's mainly sort of because I've been using it as a test application as well. But you really can go a long way with very, very small amount of code. And like I say, this also, it won't look quite as impressive, but it's certainly possible. Here's one I made earlier, because obviously I want to save you from the CPP build times. But here's the same thing, same application exactly, but using OpenFL backend under CPP. So it's exactly the same application, really, except that now this is not native anymore. This is custom drawn. So this is completely, you know, all composites. The dialogues don't look quite as good yet because they don't have, there's no shadows, so there's no filters or anything like that. But the general application is, you know, exactly the same as it was native, and nothing has changed. There's no special code here to switch between, you know, native or OpenFL. I haven't hacked anything. This is exactly the same application, simply recompiled. So I think this is pretty cool, and I'll continue to develop this and actually release it as a real tool, because I mean I think it's extremely useful. I know I'll use it certainly to upgrade and downgrade certain HaxeLibs. But yeah, so yeah, that's me. Any questions? None?
You were very clear.
Say again? Yeah, well, the release. I think we're talking weeks rather than months. I mean, I need to do a little bit more cleanup. I'm not really writing any more controls anymore. I've finished with that because I just end up spending too much time. So I would say a couple of weeks, maybe a month, depending on time. Obviously, I've got other commitments. But yeah, assuming I get the time that I can, I would say weeks rather than months. And then I'll put it up. It will be an alpha, so things won't be there. Things won't work perfectly. But it should work. I've been working on documentation as well, which I think everyone will be happy to hear finally. Maybe I'll get some peace as well. Yeah, so a couple of weeks, I would say. Weeks to months. A month.
So that's the time Rob can start contributing?
Yeah, absolutely. I mean, I'll put it on GitHub, and then, yeah, everyone can rip it apart and, because, I mean, another thing to remember is I don't know how to use car. I mean, I've had to learn how to use car in order to do this, and the same goes for Lux. So it's very, very possible that when someone looks at the back end for car, for example, they'll be like, this is crazy how you've done this. It doesn't make any sense, which is totally fine with me. So then they can look at that back end with their sort of domain-specific information and be like, okay, let's do it this way. And so then, yeah, I'll benefit from their expertise in those areas, certainly.
Do you have any plans to embed any IDE or use the Hax developer IDE for that? Yeah,
well, I don't think that I could use Hax to make an IDE, although it's certainly an option that I've been thinking about. Maybe a sort of a code editor I think would probably be a bit safer to make with HaxeUI, because you don't want that complexity. But as far as IDE goes, I use Flash Develop. And I'm thinking about writing a plugin for it that makes it easier to build layouts and that kind of stuff. I'm not sure what I would do for the like Ubuntu and OS X, because obviously Flash Develop doesn't work there. So it would be nice possibly to make something cross-platform that would work on all of them, but I haven't really thought about it. I mean, I've generally been spending most of my time actually writing the framework and thinking about tooling rather than actually implementing any tooling at all.
We've got one question from Lars on Twitter, which is, what do I need to do to make a Flixel backend?
Well, nothing really. I mean, like I say, Flixel is pretty simple in the sense that it's already got sprites. It's already got the notion of children. So sprites can be drawn on top of each other and all of that kind of stuff. So it's already essentially there. All I need to do is actually do it, which means that it has to, expose a draw function that then takes the CSS style and draws, boxes or whatever it happens to be. So what all that has to happen really is for me to simply write it. Yeah, as with most things, I guess, is just to put it up. But I think I'm going to release the code first. So I think I'm going to put it on GitHub before I start writing any more backends, which means that it's completely possible, because it's relatively simple. I mean, most of the backends sit at around 1,000 lines of code, which is really, really a small amount of code for what they do. So it's very possible that someone else, once I release it, can look at how I've done OpenFL, for example, and just simply re-implement that for Flambe. Sorry, not Flambe, for HaxeFlixel, which is, yeah, more than possible. And I think it will be a very easy backend to implement.
Can you tell us more about list views and table views?
Yeah, I mean, there's in version 1, I've got list views, and they're quite nice. I mean, you can have like a scrolling list which reuses item renderers, and it's functional. At the moment, nothing like that exists in version 2. There's a scroll view, and that's it. I want to implement list views and table views because I think that you get the reuse out of them. But what I also want to do is I want native counterparts. So, for example, there's list views in WX widgets. There's list views, I'm sure, in Qt as well. And what I want to do is have the user has the ability to do exactly the same as they would natively. But of course, that's going to throw up a lot of problems. So I need to kind of investigate how WX widgets does it, how Qt does it, then see if that applies to how I want to do it, and see if there's any middle ground. If there isn't, then maybe you will have a specialized class, native list view, native table view, possibly. But I would like to keep with the same framework and just have a list view, native equals true. That's ideal, but I don't know how they do it at the moment. So again, I'm going to put a release up on GitHub before I investigate any of that sort of stuff, because it could be months at the end of the day. So first a release, certainly. But yeah, I hope that answers the question.
Anyone else? Okay, thank you, Ian.
Cheers.